Hi friends, in this video we will discuss about 50 most important questions on electrical systems. These questions are very important from energy manager certification exam point of view. These questions have been framed from the guidebook on energy efficiency in electrical utilities. I will come with more questions on electrical systems in subsequent videos. If you like the content of this video, then please like, share and subscribe to my channel. Please do share your views in the comment box. Now coming to the first question, what does an electric power supply system consist of? Option A is power generating unit, option B is transmission and distribution lines, option C is substations, and option D is all of the above. And the answer to this question is option D, that is all of the above. Now coming to the next question, what is the role of Energy Control Center or ECC? Option A is Decision Center for Electric Transmission and Generation Interconnected System. Option B is delivers autonomous microgrid solutions managing multiple energy sources and prioritized loads. Option C is monitors and coordinates minute by minute physical and economic operation of the power system. And option D is all of the above. And the answer to this question is D, option D, that is all of the above. Now coming to the next question, about 70% of power generating capacity in India is from option A is coal-based thermal power plants, option B is nuclear energy-based power plants, option C is hydel power plants, option D is natural gas-based power plants. And the answer to this question is option A, that is coal-based thermal power plants. Now coming to the next question, the correct sequence of power generation in a thermal power plant is option A is steam generation, coal pulverization, power generation, coal blowing. Option B is combustion, power generation, steam generation, coal pulverization. Option C is coal pulverization, coal blowing, combustion, steam generation, power generation. Option D is power generation, steam generation, coal blowing, coal pulverization. And the answer to this question is option C, that is coal pulverization, next is coal blowing, next is combustion, next is steam generation, next is power generation. Now coming to the next question, the overall efficiency of coal-based thermal power plant in India varies from option A is 28 to 35%, option B is 35 to 65%, option C is 65 to 75%, option D is 75% to 95%. And the answer to this question is option A, that is 28 to 35%. Now coming to the next question, the overall efficiency of coal-based thermal power plant in India depends on option A is operational practices, option B is fuel quantity, option C is capacity utilization, option D is all of the above. And the answer to this question is option D, that is all of the above. And the next question is, which is true about heat rate? Option A is it is a measure of efficiency of power plants. Option B is amount of energy used by an electrical generator to generate 1 kilowatt hour electricity. Option C is it is expressed in kilocalorie per kilowatt hour or BTU per kilowatt hour. Option D is all of the above. And the answer to this question is option D, that is all of the above. Coming to the next question, 1 kilowatt hour of electrical energy is equivalent to option A is 860 kilocalorie of thermal energy, option B is 3600 kilojoule of thermal energy, option C is both option A and option B, option D is none of the above. And the answer to this question is option C, that is both option A and option B. And the next question is, which statement is true? Option A is heat rate is inversely proportional to efficiency of power generation. Option B is lower the heat rate, lower is the generation efficiency. Option C is higher the heat rate, higher is the generation efficiency. Option D is heat rate is directly proportional to efficiency of power generation. And the answer to this question is option A, that is heat rate is inversely proportional to efficiency of power generation. And the next question is, what are the parameters produced by a typical power plant? Option A is frequency 50 Hz alternating current. Option B is voltage 11 kilovolt to 33 kilovolt. Option C is three-phase voltage. Option D is all of the above. And the answer to this question is option D, that is all of the above. And coming to the next question, why high voltage transmission lines are used? Option A is smaller wire size can be used. Option B is more economic. Option C is to carry lower current and to reduce losses. Option D is all of the above. And the answer to the question is D, that is all of the above. Now coming to the next question, what is the role of substations in electrical system? Option A is increases voltage by using step-up transformer. Option B is reduces voltage by using step-down transformer. Option C is voltage is increased for distributing it to an industrial users. Option D is none of the above. And the answer to this question is option B, that is reduces voltage by using step-down transformer. Now coming to the next question, what is the main difference between transmission line and distribution line? Option A is high voltage transmission lines transmit large amount of electrical energy over long distances. Option B is distribution lines carry limited quantities of power over short distances. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, which statement is true? Option A, for the same quantity of power handled, lower the voltage, higher the current drawn. Option B is for the same quantity of power handled, higher the voltage, higher the current drawn. Option C is current drawn is directly proportional to the voltage for the same quantity of power handled. Option D is none of the above. And the answer to this question is option A, that is for the same quantity of power handled, lower the voltage, higher the current drawn. Now coming to the next question, which of the following factors are responsible for voltage drop in transmission and distribution lines? Option A is resistance and reactance of line. Option B is length of line. Option C is current flow in the line. Option D is all of the above. And the answer to the question is D, option D, that is all of the above. And the next question is, what is the primary function of transmission and distribution equipment? Option A is to transfer power economically from one location to another location. Option B is to transfer power reliably from one location to another location. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, how energy is wasted in transmission lines? Option A is it is wasted in the form of voltage drop. Option B is it is wasted in current drop. Option C is it is wasted in frequency loss. Option D is it is wasted in the form of I square R losses. And the answer to this question is option D, it is wasted in the form of I square R losses. Now coming to the next question, what is the function of a capacitor? Option A is to reduce the current flow. Option B, to reduce electrostatic energy in an electric field and where possible to supply this energy to the circuit. Option C is to correct power factor by causing the current to lead the voltage. Option D is both option B and option C. And the answer to this question is option D, that is both option B and option C. Now coming to the next question, what happens to the operating efficiency of an electrical system when AC currents are kept in phase with voltage? Option A is operating efficiency is maintained at a low level. Option B is operating efficiency is maintained at a high level. Option C is operating efficiency is maintained at the same level. Option D is none of the above. And the answer to this question is option B, that is operating efficiency is maintained at a high level. Now next question is, which of the following are circuit interrupting devices? Option A is switches and relays. Option B is circuit breakers and fuses. Option C is both of the above. Option D is none of the above. And the answer to this question is option C, both of the above. Now coming to the next question, what is one of the most important characteristics of circuit breaking devices? Option A is to break the circuit. Option B, to make the circuit. Option C, making and breaking the current carrying conductors with minimum arcing. Option D is none of the above. And the answer to this question is option C, making and breaking the current carrying conductors with minimum arcing. Now coming to the next question, which is true about relays? Option A is relays sense abnormal voltages, currents and frequency. Option B is it operates to protect the system. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, what is the role of transformers in transmission and distribution system? Option A is to minimize power losses. Option B to increase the voltage. Option C to decrease the voltage. Option D all of the above. And the answer to this question is all of the above. Now coming to the next question, the two-part tariff structure used in electricity billing of high tension category involves option A, one part for capacity or demand run, that is kVA or kilowatt. Option B is second part for actual energy drawn during the billing cycle. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, what role does the reactive energy play in utilities? Option A is this affects the load on utility. Option B is it regulates the voltage. Option C is it helps to move power effectively through utility grid and transmission lines to where it is required by the load. Option D is all of the above. And the answer to this question is D, all of the above. And the next question is, which is true about reactive power? Option A is it is reflected by the power factor. Option B, it is the product of voltage and that part of the current that is in phase with the voltage. Option C is it is that portion of power that is absorbed and used by the load. Option D is it is always equal to or less than the reactive power. And the answer to this question is option A, it is reflected by the power factor. Now coming to the next question, electricity tariff structure generally includes the following. Option A, maximum demand charges and energy charges. Option B, power factor penalty or bonus rates. Option C, penalty for exceeding contract demand. Option D, all of the above. And the answer to this question is D, all of the above. Now coming to the next question, the role of energy manager in electricity billing is option A, to analyze utility bill data. Option B, to monitor utility bill trend. Option C, to identify ways for electricity bill reduction through available provisions in tariff framework and energy budgeting. Option D is all of the above. And the answer to this question is option D, that is all of the above. Now coming to the next question, what are the minimum outputs from electromagnetic meters? Option A, maximum demand registered during the month. Option B, active and reactive energy during the billing cycle. Option C, apparent energy during the billing cycle. Option D is all of the above. And the answer to this question is option D, that is all of the above. Now the next question, what is the maximum demand registered during a month? Option A is it is the instantaneous demand drawn. Option B is time integrated demand over a predefined recording cycle. Option C, optimum level of electrical demand monitored in a particular period, usually for a month. Option D, maximum demand is equal to connected load multiplied by load factor. And the answer to this question is option B, time integrated demand over a predefined recording cycle. Now coming to the next question, in an industry, if the drawal over a recording cycle of 30 minutes is 3000 kVA for 4 minutes, 3600 kVA for 12 minutes, 4000 kVA for 6 minutes, 4200 kVA for 8 minutes, then the maximum demand will be option A is 3500 kVA, option B is 3700 kVA, option C is 3800 kVA, option D is 3760 kVA. And the answer to this question is option D, that is 3760 kVA. Now coming to the next question, what is the month's maximum electricity demand for an industry or a facility? Option A is highest demand among demand values recorded in a month over a predefined recording cycle. Option B is average of the demand values recorded over the month. Option C is highest instantaneous demand value recorded over the month. Option D is none of the above. And the answer to this question is option A, highest demand among demand values recorded in a month over a predefined recording cycle. Now coming to the next question, an industry or a facility has to pay monthly electricity charges as per option A, the cumulative sum of the instantaneous electricity consumed. Option B, the average electricity consumed for the whole month. Option C, highest demand value registered for the predefined recording cycle. Option D is none of the above. And the answer to this question is option C, highest demand value registered for the predefined recording cycle. Now coming to the next question, what is the type of energy meter used by most electrical boards nowadays? Option A is electromechanical trivector meters. Option B is electronic meters. Option C is standard meters. Option D is dial meters. And the answer to this question is option B, that is electronic meters. Now coming to the next question, some of the advantages of electronic meters over electromechanical trivector meters are: option A is substantial memory for logging and recording all relevant events. Option B is tamper detection or recording. Option C is long service life due to absence of moving parts. Option D is all of the above. And the answer to this question is option D, that is all of the above. Now coming to the next question, which statement about accuracy of measurement of electronic meters is correct? Option A is accuracy up to 0.1 class. Option B is accuracy up to 0.2 class. Option C is accuracy up to 0.3 class. Option D is none of the above. And the answer to this question is option B, that is accuracy up to 0.2 class. Now coming to the next question, harmonics and total harmonic distortion or THD can be measured in which type of energy meters? Option A is standard meters. Option B is electromechanical trivector meters. Option C is electronic meters. Option D is solid state meters. And the answer to this question is option C, that is electronic meters. Now next question is, amenability for remote data access or downloads is possible in which type of energy meters? Option A is standard meters. Option B is electromechanical trivector meters. Option C is electronic meters. Option D is solid state meters. And the answer to this question is option C, that is electronic meters. And coming to the next question, why trend analysis of purchased electricity and cost components is done in an industry? Option A is it is useful. Option B is it is effective. Option C is variation in purchased electricity and cost components can be observed. Option D is to identify key result areas for bill reduction within the utility tariff available framework. And the answer to this question is option D, to identify key result areas for bill reduction within the utility tariff available framework. Now coming to the next question, why load management is required in an industry or in a facility? Option A is as capacity addition is costly and only a long time prospect. Option B is to minimize peak demands on the utility infrastructure. Option C is for better utilization of power plant capacities. Option D is all of the above. And the answer to this question is option D, that is all of the above. Now coming to the next question, what type of measures are adopted by power distribution companies in power tariff structure to influence end user in better load management? Option A is time of use tariffs is introduced. Option B is penalty imposed for exceeding allowed maximum demand. Option C is night tariff concessions are introduced. Option D is all of the above. And the answer to this question is option D, that is all of the above. And the next question is, what is the daily load curve? Option A is the plot in which daily demands are plotted over a month. Option B is the plot in which hourly demands are plotted for a single day. Option C is the plot in which daily demands are plotted for a week. Option D is the plot in which daily demands are plotted for a fortnight. And the answer to this question is option A, the plot in which daily demands are plotted over a month. Now coming to the next question, what is an hourly load curve? Option A is the plot in which daily demands are plotted over a month. Option B is the plot in which hourly demands are plotted for a single day. Option C is the plot in which daily demands are plotted for a week. Option D is the plot in which daily demands are plotted for a fortnight. And the answer to this question is option B, that is the plot in which hourly demands are plotted for a single day. Now next question is, what is the use of hourly and daily load curves? Option A is they are useful in predicting patterns of dwell. Option B is they are useful in analyzing peaks and valleys in energy use. Option C is they are useful in analyzing energy use trend in an industry. Option D is all of the above. And the answer to this question is option D, that is all of the above. Now coming to the next question, why rescheduling of large electric loads is required in an industry? Option A is to average out the electric loads. Option B is to minimize simultaneous maximum demand. Option C is to improve the load factor leading to maximum demand reduction. Option D is both option B and C above. And the answer to this question is option D, that is both B and C above. And the next question is why building up storage capacity of products or materials is required from energy management point of view. Option A is to reduce maximum demand. Option B is electricity can be used during peak off-peak periods. Option C, off-peak hour operations help to save energy due to favorable conditions like lower ambient temperature. Option D is all of the above. And the answer to this question is option D, that is all of. And the next question is why ice bank system is used in milk and dairy industry. Option A is ice is made in lean period and used in peak load period. Option B is to reduce maximum demand. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, what is the function of sophisticated microprocessor based demand monitoring and control systems? Option A is accurate prediction of demand, graphical display of present load, available load and demand limit. Option B is automatic load setting in a predetermined sequence. Option C is recording and metering, automatic restoration of load, gives visual and audible alarm. Option D is all of the above. And the answer to the question is option D, that is all of the above. Now coming to the next question, what is the role of diesel generator sets in electric utilities? Option A is to supplement the power supplied by electric utilities when demand reaches the peak value. Option B is to reduce the load demand to a considerable extent and minimize the demand charges. Option C is both option A and option B, and option D is none of the above. And the answer to this question is option C, that is both option A and option B. Now coming to the next question, why capacitor banks are used at plant level? Option A is it is useful in reducing maximum demand. Option B is it is used to maintain optimum power factor. Option C is both option A and option B. Option D is none of the above. And the answer to this question is option C, both option A and option B. With this video, we come to the end of 50 questions on electrical systems from the guidebook on energy efficiency in electrical utilities. I'll be sharing more such videos in my channel. I again request you to like, share and subscribe to my channel if you like the video.